Everybody, I want to talk to you about the geometric mean today. So these are our geometric mean notes. This first section here is all warm-ups of what we did in simplifying radicals. You can see that video if you want more explanation on how to do that. But for right now, let's focus on just the geometric mean. The geometric mean is a proportion that uses the same piece twice. So you notice in this proportion, you have x here and x here. All right. The piece that's used twice is called the mean. So the geometric mean is going to be x, and the part we call it the means. The parts that are not used twice are the extremes. Okay. Got a couple examples here. To find the geometric mean of 3 and 12, I've got the mean in here twice, and I want to put one extreme, the 3 here, and another extreme, the 12 here. Then you're just going to cross multiply. Well, 3 times 12 is 36, and x times x is x squared. So what you can do is you can solve for x by finding the square root on both sides of that equation. So x equals the square root of 36, which is 6. So there you go. 6 is the geometric mean of 3 and 12. Let's try it again. This time we're going to set up our own proportion. I'm going to put a 4 on top, x here, x on top, and then a 17 right here. Of course, we're going to cross and multiply. So we end up with x squared is equal to 4 times 17, which is 68. We want to find the square root there. Now, 68 isn't a perfect square, so we need to find the prime factors. We end up with x equals these prime factors, okay? So 2 times 2 times 17 gives us 68. And then we've got this pair of 2's that comes the outside. So x equals 2 radical 17. So 2 radical 17 is the geometric mean of 4 and 17. Okay, I want to take a moment to talk to you about triangles, okay? The geometric mean exists in right triangles through the geometric mean or altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into 2 segments. The length of this altitude is the geometric mean between the lengths of these 2 segments. Okay, all right, so basically what we're saying here is that h, if it's an altitude, is the geometric mean between x and y. So triangle, if you have a right triangle and you draw an altitude, what happens is that you create 2 other right triangles, one there on that side of the altitude and one here on this side of the altitude. And what's really neat about these triangles in this sort of configuration of these triangles is that they are all similar triangles. So if I pull them all apart, a little bit more here. If I pull them all apart, then I can line them all up, and you can see that they are all similar triangles. That one's not as easy to see. Maybe if I zoom in. Should have been a different color. They're all similar triangles. So you can say that like these, because they're similar, right? The hypotenuses all correspond, and the short sides all correspond, and the longer sides all correspond. But depending on how they're oriented in the picture, you might have to do a little bit of thinking about how everything lines up. Okay, so CD is the geometric mean between AD and DB, between those segments. Okay, x over h is equal to h over y. And another way to put that would be to say that h is equal to the square root of x times y. Okay? All right, let's practice a couple of these. Now, here z is the altitude, and the two extremes that we have are 8 and 25. So we're going to set up a proportion with z here and here. 8 is one extreme and 25 is the other extreme. And you probably noticed I put the small one here and the larger one there. That's just me. There's no rule that you have to do that. Okay, so you would want to cross multiply. Let's go ahead and do that. Z times z is z squared. And let me zoom in on this a little bit. And 8 times 25 is 200. So to find what just z is, we're going to find the square root of 200. In this case, it is 10 radical 2. All right, let's solve another one. This time we have the altitude. So we already have that geometric mean. The 12 is going to go here and here. And we're looking for the extreme. So I've got x here and I've got 9 here. Okay, cross multiply. 12 times 12 is 144. And that's equal to 9x. Divide on both sides by 9. That cancels, and I have this 9, and I have 16 equals x. Okay, the last one that we're going to do here, again, they've given us the altitude, and we've got the two extremes here. I've got this extreme and that extreme. So when I set up my proportion, I'm going to put a 12 down here. That's one mean, and a 12 up here. That's the other mean. I'm going to put one of the extremes here, 24. And here, in parentheses, I'm going to put this expression, t plus 1. All right, so then cross multiply. So 24 times t plus 1 is equal to 144. Then you want to distribute, right? So multiply 24 times t and 24 times 1. So 24t plus 24 is equal to 144. I'm going to do a little bit of algebra here, right? Subtract the 24 on both sides. You end up with, I'm going to move over here, sorry. 24t is equal to 120. Then divide both sides by 24. That cancels over here. And t equals 5. Oh, you can't see what I wrote there. Okay. T equals 5. All right, so this extreme here would be 5 plus 1, or 6. So the geometric mean between 6 and 24 is 12. Okay, go work on those practice problems. Have a great day.